Assalamualaikum warahmatullahi wabarakatuh. Well, in this video, I'm going to extend the idea of finding the expected value of EX. Now, sometimes the interest is not just on finding what is AX, but maybe we will be interested to find the expected value of other random variable that is related to X. Let's say Y. For example, what if the expected value of Y when Y is equal to 3X? So you can see that Y here is related to X in this manner. Now, what if you want to find the expected value of Y when Y is equal to X cubed? So these are examples of having another random variable. We can call it Y, where Y here is related to X or depending on X, okay? And in order to make it more general, we can represent Y as a function that depends on X. So we call it Gx. And therefore, in this video, we are interested to extend the idea of Ex and to find the expected value of Gx. Okay, so that is what we're going to look at in this video. We are extending the idea of Ex to finding expected value of a function that depends on X. Therefore, the idea is very simple. What you need to do is, if you want to find the expected value of Gx here is a function that depends on X, then what you need to do is you just need to plug in Gx right next to Fx, and you need to find the product of these two items here, and then you just go on and follow the same process of summing up with respect to X. And this is clearly the case of a discrete case. Okay, so when you have a discrete random variable, you're dealing with summation, and if you have a continuous random variable, then you'll be dealing with integration, as what you have seen many times in the previous videos. Okay, so it is very easy. The concept gets extended quite easily. For example, again, let me just tell you, if you're looking to find the expected value of X, then what you need to do is we just need to have X right next to Fx, and this is what you have seen in the previous video. So now we are interested to find expected value of Gx. Gx is a function of X, so what you need to do is you just need to replace the whole Gx right next to Fx. So the idea is very simple. Just substitute whatever that you need to find right next to Fx. So similarly for this one, Gx is what you are interested to find. So just substitute that right next to our Fx. And then for continuous case, what you need to do is you just need to integrate those expressions right here. Okay. Now let's look at examples, and I hope with examples it becomes more clear and you guys have better understanding on how we can do that. Okay. Right, so here is a discrete case example where X represents the number of points rolled with a balanced die, and you got to find the expected value of this function. Okay, so when you want to find the expected value of something, we need to find, of course, Fx. And in this case, because the function is given as Gx, then we're going to substitute that right next to Fx. But of course, apart from Fx, you need to find what is the value of X as well. So those two are the first steps that you have to do. You need to find what is X and what is Fx. And clearly from this simple example, if you talk about the number of points that you can get with a balanced die, basically you can have the values of X equal to either 1, 2, 3, 4, 5, 6, because you're talking about a balanced die, and of course the value of Fx in the case of a balanced die is going to be 1/6 for each outcome, really. Okay, so we are done with finding x, we are done with finding fx. So that is the basic process that we have to do. Right now, what we're going to do is we're going to come up with finding the expected value of this one, gx. So gx is 2x squared plus 1. Therefore, according to the formula, we're just going to substitute this expression right next to fx. So this is summation process, this is x. Just take on the whole thing and put it right next to fx. Okay, so that's the process. So now, what is this thing mean is you have to keep on changing the value of x accordingly. Okay, so you can see that the value of x is 1, 2, 3, 4, 5, and 6, and so you're going to change it accordingly every time. Right now, what we're going to do is we're going to see when x is equal to 1, what happens here is going to be 2 times 1 plus 1, right? Times f1. Okay, so that is the first one. Next, we're going to change x to the value of 2. Okay, so 2 times, this one is 4, 2 to the power of 2 is 4, plus 1 times f2. Okay, so that's the process. Next, 2 times 9, okay, 3 to the power of 9, and plus 1 times f3. Next is 2 with 4, so 4 is 16, plus 1 times f4. Next is 2 times this one, 5. 5 squared is 25, plus 1 times f5. And finally, we have x6. So we have 2, 6 squared is 36, plus 1 times f6. Okay, so that's the process. Now, let's just simplify the whole thing. So this one is 3 times, what is f1? f1 here is when x is equal to 1, f1 is 1 over 6. So 3, 1 over 6. Plus, this one is 8 and 9. What is f2? So when x is 2, this is 1 over 6 as well. Okay, this one is 18, 19. So 19. The same thing, f3 is also 1 over 6. Okay, you are multiplying with that. And then this one is 32. So 32, 33. 33 times 1 over 6 for f4. And then this one is 50, 51. 51. 1 over 6 for this one, f5. And finally, 36 and 2 is 72, 73. So 73, 1 over 6. Okay. Punch in these values into your calculator. You will be able to get that the expected value is going to be around 31.3333. Okay. So that's the process. Okay, let's move on and see example of finding expected value of a function when we are dealing with a continuous random variable. So here we have random variable x, where it has the probability density. So when we talk about probability density, we immediately know that we're dealing with a continuous random variable. And you are asked to find the expected value of this function right here. Therefore, what you need to do is you have to find what's the expected value of e, and here we have 3x over 4. And then, as I've said earlier, what you need to do is we're just going to take this whole thing right here and put it right next to our fx. So our fx is this one. So I'm just going to write down our fx is this one, and we'll integrate that with respect to dx. So this is the function, this is gx, and this is fx, yeah? And the limit will be from 0 to infinity. Okay, 0 to infinity. And what we can do is we can consider them together. So 3x over 4 minus x. So what we have is we're going to have e 3x minus 4 over 4 minus x dx. Okay, we're just grouping them together, so that will be easier. So then it will be infinity 0, this will be e, and this will be negative x over 4 dx. Okay. Right, and we know how the answer is going to be for this one. If you integrate this expression here, what you will get is you will get the same result, but at the bottom here will be negative 1 over 4. And here will be the limit from infinity, from 0 to infinity. Okay, and this one can be modified so that it becomes negative 4 e x to the power of x over 4. Yeah, so here this is what we have, and you can start substituting the limits accordingly. So what we have next is this one is going to be equal to negative 4. This one is e infinity over 4. So minus and negative is going to be plus. So 4 e 0 over 4. Now you can see that this result at the bottom here is going to be such a large number. And so when you have negative 4 divided with such a large number, the result is going to be equal to 0. Plus, this one is e, and then this is 0, e 0 is 1, so plus 4. Okay, so final answer is the expected value for this function is going to be equal to 4. Alright, I think that's all for now. Thank you very much for watching.